Welcome to qnawire.
To solve these, we're working with a binomial distribution because the scenario involves a fixed number of trials with two possible outcomes for each trial. So for the first part, I don't know what your options are, the correct wording for the random variable, but it should be the random variable x is the number of defective items out of 124 randomly chosen items. N would be equal to 124 and P would be equal to 0.75, which is the probability that an item is defective, and there are 124 items. And so that would be C. Now for part D on, we need to use the formula, the binomial distribution formula, which says that the probability that x is equal to some value k is equal to n choose k times the probability of success to the power of k times the probability of failure to the n minus k times. And so for D, we want the probability that it is exactly 92. So by hand, that would be 124 choose 92 times the probability of success 92 times, and failure, which would be 0.25, 124 minus 92, which is 32 times. And we want that to 4 places. Let me get that into a calculator. .0799. Now, on to part E. The probability that less than 92, this you're going to want a calculator for. This is pretty extreme. Like if you use the decimals graphing calculator, you just do binomial distribution with 124 trials and the success is 0.75, hit the box, and then you can give ranges. So for less than 92, that's the same as the probability that x is less than or equal to 91. And so you can set the maximum to 91 because it has to go to integers, and 92 is not included in this. So if you set the maximum to 91, that's 0.3720. More than 92 would be the probability that x is greater than or equal to 93. And so you would, in this case, set the minimum to 93. And that is 0.5481. And next, exactly 93. You could do by hand, or you can set the min and max to both be 93 and that would be 0.0825. At least 93 would be greater than or equal to 93. And so in this case, you would set the minimum to 93. And so that is 0.5481. And the probability that at most 93 would be less than or equal to 93. And at most 93 would be 0.5344.